All right, let's talk about AI and machine learning. You hear these terms thrown around all the time, right? Often like they mean the exact same thing. But they don't, not even close. So today, we're going to cut through all that noise and figure out what the real difference is.
So let's start with the big picture, artificial intelligence. You can think of AI as the huge umbrella concept. It's the grand dream, really. The idea that we could create machines that can think or act in ways we'd consider smart. And this isn't a new idea at all. It goes way back, from old stories about thinking statues to the sci-fi robots we all know and love.
But getting from that dream to where we are today, well, it wasn't exactly a straight shot. To really get what makes machine learning different, we've got to take a quick look back at the journey.
Okay, so the term artificial intelligence officially gets coined back in 1956, and it was just this massive wave of excitement. People thought we were on the verge of creating thinking machines. But the hype got way ahead of the reality. The tech just wasn't there yet, and when those big promises didn't deliver, the funding, well, it just vanished. This whole period is famously known as the AI winter. It took until the 80s for things to thaw out, thanks to a completely different way of thinking. So what was that first approach? It was called symbolic AI. Some people even call it good old-fashioned AI. And the whole idea was basically to write a giant, exhaustive rulebook for the computer. You'd have human experts literally sit down and code every single possible rule they could think of. If you see this, then do that. It was a super top-down approach, trying to handcraft intelligence piece by piece.
The problem was, this rulebook approach was, well, it was really brittle. The real world is messy, it's unpredictable, and you just can't write a rule for everything. This is where everything changed. A new, game-changing question popped up. What if, instead of feeding the machine rules, we could get it to learn the rules for itself?
And this is a fantastic way to think about that shift. Symbolic AI is like a chess grandmaster who has studied and memorized every opening, every strategy, every rule in the book. But machine learning? That's more like a student who learns to play chess by, playing thousands and thousands of games. They start off clumsy, but they learn from experience, spotting patterns and getting better over time. It's programming versus learning.
And that gets us to the absolute heart of it. In the old way of doing things, the traditional way, a human programmer has to sit down, figure out the logic, and write out all the rules. But machine learning just flips that whole process on its head. Instead of rules, we give the computer a ton of data and tell it what a good answer looks like. Then, it's the machine's job to figure out the patterns and essentially write its own rules to get there.
So there you have it. Machine learning isn't a different thing from AI. It's a part of AI. It's a specific, powerful technique to achieve that bigger dream. It's the engine that powers modern AI by letting machines learn directly from data without humans having to program every single step. Okay, this chart really breaks it down nicely. On one side, you've got symbolic AI. It runs on rules we give it, so it doesn't need much data. The big plus? We can look inside and see exactly why it made a decision. It's a transparent box, but it's super rigid. Then you have machine learning. It needs mountains of data to learn from, which makes it incredibly flexible and adaptable. But here's the catch. A lot of the time, its reasoning is a black box. We know it works, but we don't always know how. Now, this is the really important part. Machine learning isn't science fiction anymore. It's not some concept from the future. It's here, right now, and it's running behind the scenes in so many parts of your daily life, probably in ways you don't even think about.
Think about your email inbox, for example. The reason it's not completely flooded with junk is because a machine learning model has looked at billions of emails and learned to spot the patterns of spam. It's doing that filtering for you constantly.
Or how about the photo app on your phone? You know how you can search for beach or dog and it just finds them? That's machine learning. It's learned to recognize faces, objects, and even tell your cat photos from your dog photos because it's seen millions of examples of both.
And of course, there are the recommendation engines. I'm talking about Netflix, Amazon, Spotify, the ones that sometimes feel like they know you better than you know yourself. They're constantly learning from what you watch, buy, and listen to, all to predict what you'll want next. It's all machine learning. And just how big of a deal is that? Get this. For a giant like Amazon, an estimated 35% of all their sales come from that recommendation engine. 35%. That's just a staggering number, and it shows you the real-world power of this stuff.
But of course, with all this incredible power comes some pretty serious challenges. As these systems become more autonomous and weave themselves deeper into our lives, we're starting to run into some really complex problems.
You know the old saying, right? With great power comes great responsibility. And it's never been more true. When you've got algorithms making decisions that affect people's lives, we have to talk about the risks. We have to understand where things can go wrong.
And three of the biggest risks that keep researchers up at night are algorithmic bias, data privacy, and something called poisoning attacks, which is basically tricking the AI.
Let's talk about bias first. There's a simple rule here: garbage in, garbage out. An AI model is only as fair as the data you train it on. So if you train a hiring AI on decades of company data that, for example, favored hiring men over women, well, guess what? The AI is going to learn that bias and just keep on doing it. Then there's the danger of these systems being deliberately tricked or poisoned. And this is pretty scary stuff. Researchers have shown that with just a few small, almost invisible changes, you can fool an AI. Imagine a self-driving car's camera being tricked into seeing a stop sign as a speed limit sign. The consequences, as you can imagine, would be absolutely disastrous.
So where do we go from here? What's next? Well, the future probably isn't an either-or choice. It's not symbolic AI versus machine learning. The real magic might just be in combining the two.
Right now, some of the most exciting research is in what are called neurosymbolic systems. The whole idea is to build a hybrid, to take the incredible pattern-finding ability of machine learning and combine it with the clear, logical, step-by-step reasoning of old-school symbolic AI. You get the learning power and the ability to understand how it's thinking, the best of both worlds. And really, that brings us to the final, most important takeaway. Artificial intelligence, machine learning, these things aren't some force of nature that's just happening to us. They are tools. Incredibly powerful tools, yes, but tools nonetheless. And it's up to us, all of us, to have a say in how they're used and to really think about what kind of world we want to build with them.